Good morning and good afternoon, everyone. This is Junwei from CMCC Research Institute. Today, I will share some thoughts and visions on 50G-PON in terms of technology standard and ecosystem. Okay, now I will start it. The slides consist of two parts. First part is about requirement and analysis of the 50G-PON. Second part is to discuss technical solutions and the current status of 50G-PON. According to the information from media, annual network traffic growth rate is up to 28.7%, which means traffic increases by 2 times every 3 years. If we analyze the traffic composition further, it could be uncovered that video dominates main traffic. What's more, new video service experience such as 4K, 8K, and even VR requires higher bandwidth. Here are some monthly wireline broadband operation and customer data of CMCC, from which we could see that the number of fixed broadband user scale has reached 215 million by this February, and the individual user access bandwidth is more than 100 megabit. In order to meet the current bandwidth requirement, PON has been upgraded into gigabit system, which means all of the ORTs in the urban area could support 10G PON port since 2021. Meanwhile, relevant research work on next-generation PON has started to match new scenario in the future, and the 50G PON field trial is on agenda as well. From the figure below, it's informed that in 2009, CMCC began to massively deploy GPON in field network, and we began to deploy XG-PON in 2016 and XGS-PON in 2018. If we think about the deployment experience of GPON and XGS-PON, the time interval between two adjacent generations of PON system, such as GPON and XGS-PON, is likely around 7 years. So 50G-PON is likely to be deployed from 2023. Accordingly, 50G-PON standard series is expected to be consented by 2021. A field trial and a commercial test of 50G-PON could start from 2023. One of 50G-PON technical requirements is to support smooth evolution. From our point of view, since adjacent generations of PON need to coexist, it's preferred for us to utilize GPON wavelengths for 50G-PON to support coexistence with XGS-PON as an infrastructure of access network. ODN is not easy to deploy, and the cost is high, so reuse of ODN is a key requirement to be considered in the evolution of PON. All ODNs on China Mobile's field network are deployed based on Class C+. To reuse existing ODNs, power budget need to meet 32 dB requirement for 50G-PON. The combo method is a relatively convenient method to support ODN reuse based on experience upgrading of GPON to XGS-PON. Another one of 50G-PON technical requirements is to support a new scenario. In 5G small cell backhaul, 50G-PON could be required, and the feature of 50G TDM-PON might match the requirements of backhaul for 5G small cell well, such as the topology of P2MP, which may reduce the cost. Thus, the demands for 50G TDM PON probably would be ahead of schedule, and delay and synchronous performance should be further improved. According to 3GPP TR38.913, different services have various demands on delay. URLLC service need a 0.5 microsecond delay, and EMBB service need a 4 millisecond delay from end to end unidirection, including ratio delay, core network delay, and transmission distance delay. Given the demands of the backhaul for splitting and aggregation ratio will be less than fixed broadband scenario, the demanded bandwidth for each OU will range from 10G to 1G. The delay is expected less than 350 microseconds, and the synchronous accuracy is expected less than 50 nanoseconds. 50G PON is a pretty promising PON technical to match them. So in addition to higher bandwidth, 50G PON should have a new ability to support lower delay and higher synchronization accuracy, as well as multi-service integrated access, so that 50G PON can access both traditional fixed broadband service and backhaul traffic from 5G small cell. The following will discuss the corresponding key texts to support the key features mentioned above. The key features of 50G PON required include high power budget at high speed, and lower latency and higher synchronization accuracy, and multi-service integrated access. And the key texts to support the key features include several aspects that we summarized in the right side. The second part of this slides will discuss the technical solutions and current status of 50G PON. This page will discuss key technologies to realize 32 dB power budget for 50G PON. Key technologies to realize that power budget for 50G PON typically include TX and RX side technologies in optical and electronic component. 50G PON can adopt 25G or 50G EML transmitter with SOA to obtain high launch power in TX side, and high sensitivity 25G or 50G APD could be used in RX side. Additional, the DSP technologies could mitigate the dispersion penalty of 20 km and eliminate the signal distortion and ISI in the system. So the DSP technology is essential for 50G PON, and high gain FEC could be introduced into 50G PON to obtain higher power budget. So DPC FEC is standardized as the FEC method for 50G PON, while soft decision of FEC is left to further study. This page we will continue to discuss current status and expectation for 50G PON industry. At the current stage, 25G optics with DSP is a viable option for 50G PON solution. Firstly, DSP is required to compensate optical signal deterioration
due to high speed in 50G-PON. Secondly, 50G-PON based on 25G optics could benefit low cost and reliability at current stage. Moreover, 50G-PON optoelectronic components with sufficient bandwidth might alleviate the complexity in DSP. Here's a survey about the current status for 50G-PON industry. Continuous mode device and chips are technical ready. The burst mode components are still under development. Besides, mature and commercial 50G optoelectronic components with sufficient bandwidth are moving forward.
This page we will discuss 50G-PON with lower latency and higher accuracy synchronization ability required. Another focus on key texts of 50G-PON is how to approach to lower latency and higher accuracy synchronization, so the 50G-PON performance of latency and synchronization could be improved in several ways by optimizing community layer implementation. As known to us, periodical opening activation window is a basic procedure for TDM-PON to bring new OU up, but it will add additional delay to the traffic from operating ONU. So the upper left figure shows one way to alleviate delay. After using a third dedicated wavelength for SN discovery and ranging procedure, 250 microsecond delay can be reduced. The upper right figure shows another way to do so. Multi-burst in 125 microsecond frame time means a 125 microsecond time slot is divided into several smaller sub-time slots, in which OU bandwidth allocation period can be reduced so that the traffic delay could be lower. Meanwhile, TDM-PON is such a system with natural synchronous scheme, so it's hopeful to realize 50 nanosecond synchronization accuracy after systematic optimizing.
This page we will discuss experience-oriented new OAN architecture. This architecture came up with by CMCC, which is a key feature for the next generation PON access network. There are three aspects of key characters for this new systematic architecture, including SDN, slicing, and smart. Of course, there are lots of specific text to support them, which is described right behind the key characters. This architecture could support rapid deployment for new functions efficiently and flexibly by control plane and user plane decoupled technology. Meanwhile, it could support carrying multiple service, including broadband service, 5G small cell backhaul service, and so forth, with differentiated guarantee of experience by network slicing. Network slicing is used to divide a physical network into multiple logical devices, which could reduce repeated network investments and implement. It could also increase service convergence, security, isolation, and differentiated service. And PON slicing can be mainly used in two scenarios: slicing for multiple service shared network, and slicing for multi-operator shared network.
This page we will discuss the latest progress about 50G-PON standard series. ITUT started 50G-PON standard G.98040 in 2018, and all the technical standard has consented in 2021 April with the support of the major operators and vendors in ITU-T SG 715 Q2. In order to drive PON convergence, ITU-T 50G-PON can support both 10G-EPON and XGS-PON coexistence to enable operators to upgrade 10G-EPON to ITU-T 50G-PON. In the end of the slides, here is the summary. First, based on the experience from research and deployment of GPON and XGS-PON, 50G-PON is preferred candidate technology as next generation after XGS-PON. Secondly, call for our whole industry chain to contribute to 50G-PON further, so that high power budget challenge could be overcome sooner. Thirdly, deployment requirement of 50G-PON in 5G backhaul scenario might be ahead of wireline broadband scenario. Given that 5G small cell backhaul requirement will be getting energetic from 2021, at last, the new experience-oriented architecture is a key feature for the next generation PON access network. So this is all about my presentation today. Thank you for listening.